Hello everyone, welcome back. This is Ahmed for Avionics and this is your course Mastering Docker. This section is titled Using Docker in Software Installations. So let's get started. Now, we have covered before how to use Docker, how to use the command line, how to pull images, how to run containers. But let's answer that important question, how to find the correct image. Now, let's say you have a project and this project needs a specific image for let's say, for example, WordPress. We have already worked with WordPress in the previous section. Perhaps you need also a database like MySQL. So how do you identify the image that you want or the specific image that you want? Well, an image can be identified by its name and the version of the software it contains. For example, Ubuntu, followed by a colon, and this colon will contain a tag. We'll discuss tags shortly. And this tag contains here the version of Ubuntu. It's 14.04. So this is the version of Ubuntu that this image contains. Every Docker image contains an identifier, which is a long set of numbers and characters. It gets changed whenever a change is made to the underlying files within the image. So if we run Docker images here on our example system, we are going to see all the images that I have installed locally on this machine. And as you can see here, this is the image ID. This long set of characters and numbers is the image ID. It uniquely identifies the image on the system. The same way the CID or the container ID identifies containers on the system. Okay, every time this image changes, every time a new command is added or new files are added or deleted or a change of any kind is done to this image, this number changes, indicating that this is a new image, and that of course helps identify each and every image on the system. But image identifiers of course are not human readable, so Docker users work with repositories instead. We have already covered repositories in a previous section, but let's have a quick refresher. A repository can be thought of as a large vessel containing a number of images. The repository is where images reside. You can pull an image from that repository and use it to launch containers. The repository has a name, and it's a lot similar to URLs. For example, let's say here quai.io. This is another repository that contains images /replicated.com/Negus. This is the URL of an image. Okay, it is made up of, let's see here, the registry host, which is quai.io, the username that owns the image, in our case it's replicated.com, and the image itself, which is Negus. Negus is a monitoring system based on Linux, and it happens to have an image in this repository, quai.io, where you can download it and use it. An image can be further identified by using tags. We have already seen tags in the previous sections. A tag often reflects the image version, and it is added at the end of the image name preceded by a colon. Like as you can see here, I can add here latest, which identifies this Negus image to be the latest one, regardless of its version number. I just want the latest version. And if I omitted this latest and kept on Negus just like that, it will download automatically the latest version. But I can add a number identifying the specific version that I need. So for example, I can say I want Negus version 2.5 or maybe version 3, or just leave it without any versions to install the latest one. But that is not the only possible usage of tags. In fact, an image can have more than one tag, and those tags may further identify that specific version of the image. So for example, an image might have the tag 1 and also 1.1, which means that this image is having a major number of 1 and a minor version of 1.1. So maybe another image that has only the major version of 1 is referring to the version 1.0, for example. But this one, because it has another tag which is 1.1, will identify an image that has a major number of 1 and a minor version of 1.1. Just think of tags as a complement to the image name. It just adds some more specifics to the image name to uniquely identify it and to make the user very specific about the image that he chooses to work with on the system. And of course, Docker Hub. Docker Hub is the default repository that Docker is automatically configured to use. It contains a large number of images, and they get identified, of course, by name and tags, as we have discussed. Now, in order to find an image, you have to find the repository owning that image. But how do you find that repository? That is the job of indexes. Think of images just like when you work with search engines. Let's say when you go to google.com, for example, and you want to search for a string for something, you go to the search page and you enter the strings or the keywords that you want Google to search for, and it gives you the results. This is roughly the same way that an index works. It contains a catalog of the available Docker repositories, and you can search this index for the name of the repository that you need, and it will give you the results, if available, where you can work from. Let's have an example. So here, let's say I want to search for MySQL. So I will use Docker followed by the keyword or the command search followed by the strings that I want to search for. In our case, it's MySQL. Let's click enter and wait for a while. As you can see here, it returned, and it contained the repositories that contain the word MySQL. Now let's have a closer look at this output. The first column contains the name, and of course the name, as we said, contains the username followed by the image name. So for example, here we have CenturyLink. This is the username that owns the image, and this is MySQL, which is the name of the image. And this is a brief description of the image itself. Here you can say, if you have a look here, MySQL/MySQL-server, optimize MySQL Server Docker images. Here, Google/MySQL, MySQL Server for Google Compute Engine, and so on. Now let's have a look at the third column. The third column contains the stars, and the stars here refer to the number of times the user has put a star on that image. And a star is just like a Facebook like. It is just a rough way of indicating whether or not users like this image or not. However, it is by no means a way to trust an image or a way to say that an image is safe to be installed. It's just a rough way of indicating the quality of the image and whether or not it is better than other images in the same repository. So here, if you have a look here, this image is having a 2,725 at the time of this recording. It has 2,725 stars, and the second best one is having only 174. So clearly this one was found by users to be better than the others. But as we said, this is just a rough estimate. It's just a community-based estimate of the quality of the image. The next column is official, whether or not this is official. And official means that it is maintained and supported by Docker itself. And this column is very important. It specifies whether or not this image is automated. And to understand automated, you have to understand how the image is built, and that will be the first topic in the next lecture. My name is Ahmed for Avionics, and see you next.